All right, folks, we are starting with number 67. Number 67 should be a fifth. Number 68 should be 0. Number 69 is also 0. Would anybody like to talk about any of those first three? Okay. Number 70 is 1. Number 71 is 0. And number 72 is also 0. You'll notice we're getting lots of zeros here because of that proof that we did yesterday. Lots of zeros. Number 73 is also 0. Number 74 had that funny Greek symbol in it. You could have changed those to x's if you didn't like to use that, but the answer should be negative pi. Did you get it right? Yeah? Do we want to see it? See it? Oh, you got it right, but you still want to see it? It kind of looks like a no solution symbol. Okay. So, can I plug in pi? Secant stands for 1 over cosine, correct? Which is 1 over x. Yes? What is the cosine, the x at pi? What's the cosine? Where is pi? Is that over here? 180 degrees? What's the cosine over there? Negative 1. So this is really pi times negative 1, which is just negative pi. Is that okay? 75 is 1. And I believe that's where we stopped. So everybody did A-okay here? Awesome. Let's take some notes then. You all realize that in that homework, all you had to do is manipulate it to make it look the way you wanted it to look, and then plug in those identities that we proved yesterday. All right, so we today are going to introduce something that might prove to be a little bit tricky to you. We'll see, but it is called the substitution rule. You all know what it means to substitute. Take one thing out, plug something else back in. That's what we're going to be doing today. So here is the substitution rule. And this is like the mathy notation here. I have the limit as x approaches a of g of f of x. Do you guys see how that's a composition? Do you all see how f of x has been inserted into g of x? So when I ask you what's the little function, what are you going to tell me? Is f the little function or is g the little function? F is a little function that's inside of the larger function, which is g. Okay. Basically, what we're going to try and do is pick out this little function. You're going to have to be able to pick out the little function, and then we're going to do some substitution to make it work. Okay, that's the best way I can explain it without doing some examples. So the best way to go about this is to go through and do these examples. Now, a couple of these, you will notice that I don't really need substitution. If I look at this number 1, could I simply just plug in 2? And it would work, wouldn't it? But for practice sake of substitution, I want to start with something relatively easy, and then we'll move on to things that are a little bit more difficult. Fair enough? So again, you could do this without substitution, but just for practice, we are going to do substitution. Can you tell me what the little function is in this composition? What's the little piece that's inserted into the larger piece? Y'all see this piece right here? That is the little piece that was plugged into underneath the square root. Fair enough? Okay, so what we're going to do is we're going to say, let's let y be x plus 1 over x. Okay? Then we are going to do the limit of just that little piece. Notice I'm still using the same x value as the original problem, but we're only doing the limit of that itty bitty piece in there. What do you get for that limit? 2.5 or 5/2. Is everybody okay with that? So this is 2 1/2. Of course, you could write 5/2. So here's where the substitution comes in. Okay. By the substitution rule, then, we are going to say the limit of what we just got as x approaches 2 1/2. Actually, this is no longer going to be x. This is now going to be y, because didn't I say let y equal this? Everybody see that? So now I have as y approaches that. If I am substituting y in, what is this function now? If I put y in, what part of that is y? The underneath there, right? So if I make the substitution, then it now looks like this, doesn't it? Take out the inside stuff, plug in the y. And now we're going to go ahead and find this limit. Again, you could have done all of this without substitution, because I'm just going to plug it in, right? I'm going to turn it back into 5/2, because I'm going to have to take the square root of the top and the square root of the bottom, which means I'm going to have to rationalize it. And what's my final answer going to be? How we doing, folks? Basically, what we're doing is we're cutting the function into little pieces and doing the little pieces on our way to getting the final answer. Okay. All right, let's try the next one. So what do you think? What's the little function here? X squared is the little function, this piece up here. So then what we're going to do is we're going to do the limit of just that little function. Everybody seeing how I just pulled out that little piece, right? Okay, so what is the limit as x approaches -1? 1. So now I have the limit as y approaches that 1. What is my new function going to be with the substitution? What's that? Not e of x, e to the y power. See how I said let y equal x squared? So it's going to be e to the y power. And now we're going to find that limit. Well, wouldn't that just be e to the first? Yes? E is a big old long base, isn't it? So we're just going to leave it as e. Okay, that would be the exact answer. Questions? Okay, so those first two, you could have totally done without substitution. But the next one I'm going to show you requires you to do substitution. I have sine of 2x over x. Now, the first question I'm going to ask you is, can I reduce this 2x with that x? The answer is no, because the 2x is an angle, correct? And that bottom x is not an angle. You cannot reduce it. This looks really similar to that proof we just did yesterday, right? So I got to somehow manipulate that to actually make it look like that proof, and we're going to use substitution to do that. So what's the little function here? Oops, let y equal, excuse me. What's the little piece that was inserted into a larger function? What part looks like I just pluck it right out of there? What piece needs to be fixed in order for this to look like that proof we did yesterday? The 2x, that's the piece that looks out of place, right? If that's just a regular x, we would be good to use that identity. Agreed? So we're going to say let y be 2x. then the limit as x approaches 0 of 2x is what? 0. Now I have the limit as y approaches that 0 that we just got. Now here's where it gets a little bit tricky. Does everybody agree with that the numerator is sine of y? Right? If I let y equal 2x, now that's sine of y up there, agreed? My problem is I still have an x in the denominator, don't I? I don't want x's anymore, do I? I want them to be y's. So I need to manipulate this equation right here so I can use it to plug in for y. Does everybody see how I would divide by this 2? And I would have x is equal to y over 2. Everybody all right with that? Are you okay with me calling it 1/2 y? Okay, so I will have a 1/2 y down here. Now we're in business, folks, because this is my identity, isn't it? What does that piece equal? 1? Everybody okay with that? So really, I have 1 over 1/2. Well, what's 1 over 1/2? 2. That would be my final answer. Okay, now I want to recap that for you. If I go back to the original problem, could I just plug in 0 as it stands? No. But we notice that this looks very similar to one of our identities. So if I can manipulate it to look like that, we'd be in business. This 2x right here is the little function that we made equal our y. We found the limit of the little function. We made the substitution. And then we basically worked the rest of it out. This looking okay? We sure? All right, let's try another one. The first thing I'm going to ask you before we even start doing substitution here, could I actually figure this without doing substitution? If I put a 3 pi over 2 right here, first of all, how many degrees is 3 pi over 2? 270. We're down here in the unit circle, correct? What is the sign at 270? -1. So this would be negative pi over 2, correct? Where is negative pi over 2? Still 270. So I could actually do this without substitution. Agreed? But of course, we're going to do the substitution. What's the little function? What's the piece that was plugged in to the larger function? This guy right here is going to be my little function. So I'm going to say let y be pi over 2 sine of t. Then I'm going to find the limit of that little function. Okay, so we basically just did this, folks. If I put a 3 pi over 2, that's at 270. What's the sign at 270? Times pi over 2. This is negative pi over 2. That's the little limit. Now I have the limit as y approaches that value. What will this look like now for my function that I'm taking the limit of? Sine of y. So I ask you, negative pi over 2 is the same as what degree? Going backwards by pi over 2, 270. What's the sign at 270? That would be my limit. We are going to use this a lot with trig functions. A lot. If you want to go ahead and get out your unit circle, go ahead and do that if you don't already. Let's try one with ln's in it next. What does ln stand for again? What kind of log? It's a special one. Natural log, yep. Remember the base of this is e. Okay, e's and natural logs go together. Okay, so you just want to go straight to the substitution, or you want to check and see if we could do it the way it is? What do you want to do? Straight to it. Okay, so what's the little function? You guys see how a lot of times the parentheses will tell you what the little function is? Because parentheses show that you're plugging something in, right? Okay, so we're going to say let y equal the ln of x. Then I'm going to find the limit of that. Now you might need to use your calculator here if you're not very familiar with natural logs, but I think we've talked about this before. If I put an e in here, what's the natural log of e? Should be 1. Your calculator will do it for you if you don't know. You just push your ln button, push your e button, but then you're going to have to raise the e to the first power, and it should be 1. Everybody okay? All right, so now I have the limit as y approaches 1 of ln of y over, what about the denominator? What's that? Isn't it the same thing? Isn't ln of x y? Don't I have ln of x down there? So isn't this ln of y over ln? No, of just y, excuse me. How we doing, folks? A-okay? All right, well, plug in your 1. What is ln of 1? 0. So what's my limit? 0. Okay, so I really can't gauge the vibe on you guys right now. How are we doing? Doing okay? All right. Let's do another trig function. Now, I need you to be aware that in this function, it is not required that you have these parentheses on here. Okay, I could give you this problem without the parentheses, and you need to recognize that that 3x is your little function. Okay? All right, so let's say let y be 3x. Then I'm going to find the limit of the little function. What is the limit of the little function? If I plug a 0 in there, I get 0, don't I? Okay, so now I have the limit as y approaches this 0 that we just got of, what's the numerator going to be? Yep, remember, I have this right here, that y is 3x, so that piece right there is a y. Over, now here's where I have a little bit of manipulating to do. I've got 4x down here, don't I? Can I solve this equation right here for x so I can plug it in? Sure I can. How do I solve that equation for x? So this will be x is equal to 1/3 y. Everybody see where that comes from? You guys are like blank staring at me right now. Okay, so plug it in. The 4 stays, and I'm putting in 1/3 y where the x is. So really, this is sine of y over 4/3 y. Well, we're in business, folks. You see that, right? What is that? It's 1. So this is 1 over 4/3. Folks, what's 1 over 4/3? 3/4. And that would be your limit. In this problem, you could not simply plug in 0 at the beginning. Wouldn't work. How we doing? Okay. Let's try some more. Go ahead and write that one down. Do you all agree that I can't just put a 0 in? Fair enough? Yeah? Okay, so we can substitute, we can manipulate. Okay, those problems that we just did, I made you do them all by substitution. We're going to decide what the best course of action is going to be here. Okay, so take a look at this. I can't just plug in 0. You probably could guess because I have a cosine and a -1, we're trying to get cosine -1 over x, right? You guys remember that identity from yesterday, cosine of x minus 1 over x? So how can I make that happen? Do I need to use substitution, or can I use a different method here to make that work? Conjugate, I could. If I do that, is that going to make that squared get out of there? Because I don't want a squared if I'm going to use that identity, right? So how can I get rid of that squared? Factor it. Aren't those basically perfect squares up top? So what's this going to factor into? And now we're in business. Because you know that this part right here is what? From yesterday, the limit as x approaches 0 of cos of x minus 1 over x is 0. So this is really 0 times, now I'm just going to plug this in just because, even though we all know it's just going to be 0 anyways. If I put a 0 in there, what's the cosine at 0? Cosine at 0 is plus 1 is, so really this is 0 times 2, which of course is just 0. Okay, let's try another one. And this is about the time when I have students ask me, how do you know when to substitute? The answer to that is just practice. The more experience you have solving things, there'll be certain instances that tip you off to do substitution, certain instances that tip you off to do something else. Can everybody see how I've got a cosine t minus 1 on top? I just got to make a regular t on bottom, don't I? Well, does everybody see how that's a radical down there? If I can just rationalize this, won't that make a regular old t down there? The question is, how do I rationalize something that's under a third root? If it was under a square root, you guys would be off and running and you know exactly what to do, right? But it's under a third root. So how do I make that happen? Let me ask you this. If you had this in the denominator, what would you do? You would do this, wouldn't you? Yes? Because basically, this gets me a t squared underneath there, which now is just a regular old t, correct? Because squares and square roots, that means there has to be 2 of the same thing underneath there for it to be a whole number. Agreed? Well, I have a third root. So how many t's do I have to have underneath there in order for it to work out nice and neat? 3 of them, right? So how many more do I need underneath there? 2. So that means I can multiply the top and bottom by the third root of t squared. Because that is now going to get me in the denominator the third root of t to the third. How's everybody doing? Do you see how that multiplication worked? We manipulated it so it will work. What is now in my denominator? Just a t. And now that that's just a t, I have my identity. And what is that identity? 0. So it really doesn't matter what this thing is up here. The whole thing's just going to be 0. Awesome. Okay. Let's try something that looks like this. I do not have an identity for tangent yet. Okay, yet. Eventually we will. So what's your first thought for this? Sines and cosines, that's normally your instinct on things like this. So this would be the sine of y over the cos of y all over y. Well, how do I have a fraction in a fraction like that? What do I do? How do I make this look a little better? Okay, so really this would be sine of y over cos of y times 1 over y. Isn't that the reciprocal of y, 1 over y? So now I have sine of y over y cos of y. And look at what we got going on here. That's convenient, right? What does that equal, folks? So now I have to plug in this 0. What is the cosine at 0? So really this is 1 times 1 gives me a final answer of 1. It's all about manipulation. All right, let's see here. I got 3 more left for you. Let's save the best one for last here. Let's look at that one. Can I plug in 0 as it stands? No. So I need to manipulate it. Now this might be where you might think, okay, substitution because of that 2x down there, right? Possibly. But I would say let's take a different route, because isn't that a double angle that you've got a formula for on your sheet? Don't you have sine of 2x is equal to something? Yes? Doesn't that formula that you have in it have another regular old sine of x in it? You guys see that? So if I plug that in down here, it's just going to cancel with the numerator. What is it? 2 cos of x, sine of x, or something of that nature? Doesn't matter. Technically not really, but you are right. I gave it to you in this order. Everybody okay there? So now, those two things cancel, because isn't that all of that multiplication? So I can reduce that out. And I now have 1 over 2 cos of x. Well, plug in 0 now. What is the cosine at 0? And so really this answer is going to be, should be 1 over 2, or 1/2. Fair enough? You guys are just letting me roll right on through this today. No questions, nothing. Okay. Take a look at that one. I'm going to ask you what your thoughts are here. What course of action are you thinking? Okay, so Joey's telling me the top can be changed into sine squared x over cosine squared x, correct? The bottom can be changed into 1 over cosine x. So then he'd get a common denominator in the bottom, get them together, then basically we'd have to multiply by the reciprocal because that'd be a fraction in bottom, right? A lot of work, right? It will work if you do it. Easier way though, look at your sheet. Do you see an identity that has tangent and secant in it? Yes, you do. Can you read that identity to me? You said +1 on this side? Can I manipulate this to look like this? The answer is yes. All I got to do is subtract that 1 over, right? If I subtract the 1 over, it looks like that. Agreed? So I'm going to now take this and put it right there. And now that you have that, can you tell me where I'm going to go? Factor the top, perfect squares. And those cancel. And I can just put a pi in there now. Pi is at 180 degrees. Secant is the inverse of cosine. So what is cosine at 180 degrees? Flip it over because it's the inverse and it's still -1, right? What is -1 minus 1? That would be your limit. Again, masters of manipulation here. That's what you have to become. No, you don't get to do that in your personal relationships. Okay, only with math here. Manipulate it. Am I doing on time? Wonderful. Last one for us today. This will be our longest one. Can you plug in 0? If I put a 0 down here, cotangent is the inverse of tangent, correct? Which means that is what? Cosine over sine? And we're at 0 degrees. What's the cosine at 0 degrees? 1. What's the sine at 0 degrees? So that would be 1 over 0, which is undefined, isn't it? So I can't just plug it in. Do I have an identity that can relate? Well, there's only cotangents up there, isn't there? And all of those identities that you have, they all have squares in them, don't they? Which I don't have here. So this is where I'd be following Joey's cue from that last problem and turning everything into sines and cosines. Can I reduce out the cos over sine and the cos over sine? Can I cancel it out like this? No, because these are being added and subtracted. The only time you can cancel things out is when you have multiplication. All right, so what do you want to do here? Common denominator is going to be sine. So if I do that, that'll be 2x sine of x minus cos of x all over sine of x. There's my numerator. That first term had to be multiplied by sine of x. Same common denominator in the bottom, right? So this first x needs to be multiplied by sine x plus 3 cos of x all over sine of x. Is everybody okay with me putting that 3 in the numerator? It is 3 over 1, isn't it? So it is going to go in the numerator. Now I just have to flip and multiply. And if I remember, folks, I'm pretty sure I put one just like this on your test next week. What happens? See what I can cancel out, right? And now I'm going to plug in 0. Folks, not really much plugging in to do here, because if I put a 0 right here, what is this going to become? That's 2 times 0 is 0, right? Doesn't matter what the sign is. So I have 0 minus, what's the cos at 0? Over, if I put a 0 here, doesn't this whole part become 0? Plus 3 times, what's the cos at 0 again? So in my numerator, I have -1. In my denominator, I have 3. So it looks like my limit is -1/3. This is where we start getting into the good stuff, guys. This is calculus as finest here. These are not the kind of limits you guys did in pre-calc. No. Okay. That's all I got. That's your homework. Do not do number 89 in that group, please.